SQL today, and we're going over some practice and quiz for this day 7. And we'll consolidate learning from the past 6 days of practice problems and a quiz. Let's look at our SQL skills with hands-on tasks and challenging questions. So there's a sales table. It has salesperson, region, sales amount. It's saying write a query to find the total sales for each region. So you'd probably have the region specified. So you'd probably select based on the region. So select sales amount as total sales, and then define the region and then go from there. So there's only 4 regions, and then you find it based on that. And this one is average score by class. So you probably write an average score function. So you write score as average, and then try to sum up these average scores and go from there. Given the same sales table, write a query to find sales between sales total. So you have a greater than function. You probably say having then greater than like 8,000 for that one. Write a query to find all students who appear more than once. I think that one's a count or a duplicate. So yeah, let's see what else it's saying here. Which of the following statements is true? Where filter rows before grouping while having filter groups after aggregation. I think that's on the right track. Having filter rows before grouping where filters groups after aggregation. No, I think it might be the first one. What will the following query return? Select region. It's down the place count star as region count from sales. It'll basically give us the count of select region count star. The count of sales in each region. I think it's that. For this one, combining group by and having the following orders table or the query return. Select customer ID, sum the order amount as total amount from orders, group by customer ID where the total amount is greater than 400. So it's basically the sales that exceed 400, which is A, and I guess this is showing the solutions for each of the regions. So select total sales by region. You have select region, sum sales minus total sales from sales, group by region. Average score by class is select class. Average score is average score from students, group by class. High selling salesperson, select salesperson, sum sales amount is total sales from sales, group by salesperson, having total sales greater than 10K. And then students with more than one entry, it's basically select student name count as entry count from students, group by student name having entry count greater than 1. So quiz answers were A, which we had, where filter rows before grouping while having filters groups after aggregation. B is the count of sales in each region, and A is the total orders exceed 400. So pretty easy, not too complicated. Let's move on to joins, which is a very important concept in the basic version of joins, and this is day 8. So we'll go over what are joins, types of joins, syntax of joins, examples of joins, practice exercises, and summaries. So what are joins? Joins are SQL operations that combine rows from 2 or more tables based on a related column. They help in accessing data distributed across multiple tables, creating meaningful associations between data entities, simplifying queries for complex data sets. So we have inner join, left join, right join, full order, outer join. Inner join basically returns records that have matching values in both tables. Left join returns all records from the left table and match records from the right table. Right join returns all records from the right table and match records from the left table. And then we have full outer join, which returns all records when there is a match in either left or right table. So we have the syntax of join. So inner join syntax looks like this. Select columns from the table, inner join table 2, and then basically you're looking at column name on table 1 to column name on table 2. You have left join syntax, very similar, except it says left join table 2, and then you go from there. Right join syntax is also very similar, and then full order outer join similar is following the same syntax. Okay, examples of joins. Let's assume there's 2 tables, employees and departments, and if you notice in both there's department ID, which can be used as the primary key. And to find employees and their department names, you select employee name, employee.name, department name from the employees table, inner join with departments. On employees.department ID should be equals to departments.department ID, and then it basically matches based on a one-to-one relationship. So 101 will match with this one, 102 will match with this one, 103 will match with that one. There's nothing for 104. And it's matching the person's name. So it said select the name and the department name. So that's the output, and it matched based on these 2 categories. Okay, with left join, to include all employees, even those without a department, you basically do select employee name, department name from employees, left join departments, and it's a similar syntax, but the difference here is you're even getting the null value, whereas before it was 1-to-1, there was no null value there. Now you have right join, and you're going to include departments even though without employees. So select employee's name, department's name from employees, right join and departments. And over here, I guess there's a null with the name here, so I guess that's a bit wrong. So the left join would be better, but it looks like this one. there's something off about it. So somebody's in finance and there's a null value for them. That's pretty interesting. Okay, and then we have full outer join, which is same kind of syntax, and I think it's maybe giving everybody. But yeah, that's kind of how the joins work. So there's some practice exercises. You can have a table of orders and then a table of customers. Find all orders with their customer names using inner join. Use left join to list all products and their orders from products and order tables. Create a query to find departments without employees using a right join. Write a query to combine two tables, authors and books, to list all authors and books they've written using a full outer join. Modify the employees and departments examples above to include additional columns. So in this lesson today, you learned about the purpose of SQL joins, their types, writing queries using inner join, left join, right join, full outer join, and practical use cases. And then I guess in the next lesson, we'll go on to advanced joins. Thanks for listening.